So today's video is about prime factorization. So what are prime numbers? Prime numbers are numbers that can only be divided by 1 and itself. So prime numbers only have two factors. What are composite numbers? Composite numbers are numbers that have more than two factors, and they can be divided by more than just 1 and itself. What is the prime factorization of a number? The prime factorization is a multiplication sentence unique to each number that only uses prime numbers. So how do you find the prime factorization of a number? Your first step is to create a factor tree, and I'm going to show you in the next slide what that looks like. You're going to place the original number at the top of your tree. Step 2 is you're going to draw two branches below your number and find two numbers that multiply together to give you the top number. So let's say your top number was 10. You would think about two numbers that multiply to give you 10, like 2 and 5. Step 3, you're going to determine if the factors you just found are prime numbers. If a number is a prime number, you're going to circle it, and that's the end of that branch. If a number is not prime, you're going to draw two more branches off that number and keep going. The fourth step is if a number is not prime, you're going to find two factors that multiply to give you that number. And then step 5 is you're just going to keep repeating steps 3 and 4 until you have only prime numbers left. So actually, let's look at an example of a prime factorization. So we're going to start with the prime factorization of 12. So the first thing we have to ask ourselves is, what are two numbers that multiply to give us 12? Well, we know we can do 1 times 12, but we don't want to use 1 because it doesn't really help us. So we want to think of anything else that multiplies to give us 12. So we can think of 4 times 3 or 6 times 2. So in this example, we're going to use 4 times 3. So this is going to be the beginning of our factor tree. So then the very first thing we're going to ask ourselves is 4 a prime number? Meaning, does 4 only have one factor pair? And the answer would be no. 4 is not a prime number, so you're going to actually draw two more branches from the 4 and keep going. Then you want to ask yourself, is 3 a prime number? And the answer is yes, because 3 only has one factor pair. So you're actually going to circle the 3, and then that's the end of that branch. But remember, the 4, we're not done with the 4 yet because the 4 wasn't a prime number. So now we have to think about two numbers that multiply to give us 4. Well, we know we can do 2 times 2, and we know that that gives us 4. And again, we have to be asking ourselves, is 2 a prime number? And the answer is yes. So you can circle the 2 and stop. So we're going to circle this 2, and we're going to circle this 2. And as we can see, we now have all prime numbers. There's no more branches that we need to continue with. So we're actually down to our prime numbers. So now that you have all prime numbers, you can write the multiplication sentence, because your final answer actually should be in the form of a multiplication sentence. So our prime factorization would be 2 times 2 times 3. Any number that repeats needs to be shown using an exponent. So since the 2 is repeating itself, you're actually going to write this as an exponent. So then our final answer for the prime factorization of 12 would be 2 to the second power, because we have two 2's here, times 3. Now to check your answer, you're going to simply multiply the numbers together and you should get your original number. So if we were to actually check this, well, we know 2 to the second power is 4, and 4 times 3 equals 12, and our original number is 12. So that lets us know that we actually found the correct prime factorization. So in order to find the prime factorization of a number, you do have to do or complete what's called a factor tree. So in this next example, what I want to show is how the prime factorization of a number is the same no matter what factors you begin with. So as long as the two factors you start with are actually two factors that multiply to give you the top number, that your final answer should be the same. So we're going to use 20 as an example. So we know that there's a couple different things that can multiply to give us 20. We know one thing that can multiply to give us 20 would be 2 and 10. Another factor pair would be 4 and 5. And like I said, what you're going to see in this example is how even if we start with 2 and 10 in this example and 4 and 5 in this example, we're going to end up with the same prime factorization, because the prime factorization of a number is unique to that number, and it will always be the same for that number, no matter what factor pair you start with. So again, I have to be asking myself, is 10 a prime number? Well, we know that 10 is not a prime number because it has more than one factor pair, so we have to keep going. And then I have to ask, is 2 a prime number? Well, 2 actually is a prime number, so we're going to circle the 2 and we're going to stop. So then we have to ask ourselves what multiplies to give us 10. Well, we know we can multiply 2 times 5, and that will give us 10. Again, we want to ask ourselves, is 5 a prime number? And we know that 5 only has one factor pair, so 5 is a prime number. So we're actually going to circle the 5 and stop. And then again, we already know that 2 is a prime number, so we can already go ahead and circle the 2. So then the prime factorization would be 2 times 2 times 5. And again, remember, when you've got numbers that repeat themselves, you want to actually show them as an exponent. So then 2 times 2 times 5, our final answer would be 2 to the second power times 5. So then over here at this factor tree, we started with 4 and 5. So we want to ask ourselves, is 5 a prime number? And we know that 5 only has one factor pair, so yes, 5 is a prime number. So we're going to circle it and stop. Then we want to ask, is 4 a prime number? Well, we know 4 has more than one factor pair, so it's not prime. So that means we draw 2 more branches and keep going. So then the next question is, what multiplies to give us 4? Well, we know 2 times 2 gives us 4. Again, we want to ask ourselves, is 2 a prime number? And we know that yes, it is. So we're going to circle the 2 and stop. And then we're going to circle this 2 as well and stop. So again, we want to write that prime factorization, which again is going to be 2 times 2 times 5, which we've written here. And again, because the 2's repeat, we're going to show it as an exponent, which would be 2 to the second power times 5. So as you can see, even though in this example we started with the factor pair 2 times 10, and in this example we started with the factor pair 4 times 5, our prime factorization was the same. So no matter what factor pair you start with, as long as it's a factor pair that actually multiplies to give you the top number, you should end up with the same answer. So if you, and let's say the person sitting beside you, start your factor trees with 2 different factor pairs, your final answer should still be the same. So just remember that in order to find that the prime factorization of a number is a multiplication sentence that has only prime numbers, and then to find the prime factorization of a number, you actually want to create a factor tree. So don't forget to teach the tiger something that you learned in today's video.